In this video, we'll continue our discussion of lines and graphing lines. In the last video, we made a graph that looks something like this. What I want to talk about in this video is the point where the graph crosses the x-axis. Anytime the graph crosses the x-axis, that point is called an x-intercept. And what is the x-intercept in this case? It's the point right here, which, if you go back to the last video, or if you just look at the picture, is 5, 0. We also have a y-intercept for our graph. The point where a graph crosses the y-axis is called the y-intercept. And the y-intercept on this graph is going to be 0, 5. So let's say we have the equation of a line. And what we'd like to do is we'd like to find the x and y intercepts of this line. Let's say the line is 3x minus y equals 9. And what we want to do is we want to find the x and y intercepts. The question is, how do we do that? We can see the key for understanding x and y intercepts by looking at this graph up here. Take a look at the y-intercept and look at the actual x and y coordinates. You'll notice that wherever we have a y-intercept, our x value is always going to be 0 because the x value on the y-axis is always going to be 0. That's why we have a 0 as our x value on our y-intercept. For x-intercepts, you'll notice that the y value is always going to be 0. Wherever a graph crosses the x-axis, the y value will always be 0. So from this observation, we have a couple of rules for finding x and y intercepts. And here they are. To find the x-intercept of a graph, you substitute in y equals 0 and solve for x. To find the y-intercept of a graph, substitute in x equals 0 and solve for y. Let's do it with this example. Let's start with the x-intercept. To find our x-intercept, we substitute y equals 0 into our equation and we solve for x. So we're going to substitute y equals 0 into our equation. That gives us 3x minus 0 equals 9. And we solve that equation to find our x value of our x-intercept. This simplifies to 3x equals 9. We divide both sides by 3, and we get x equals 3. So what is our x-intercept? Well, it's a point, and its x value is 3, and its y value is always going to be 0 for an x-intercept. So the x-intercept is 3, 0. Let's do the same thing with our y-intercept. The rule is, to find a y-intercept, we substitute in x equals 0 now, and we solve for y. So let's substitute x equals 0 into our equation. We have 3 times 0 minus y equals 9. 3 times 0 is obviously 0. And we're just left with negative y equals 9. We can divide by a negative 1, and that's going to give us y equals negative 9. So what is our y-intercept? Well, our y value is negative 9, and our x value of any y-intercept is always going to be 0. So our y-intercept is going to be 0, negative 9. The cool thing about finding x and y intercepts is you can actually use them to find the graph of a line. So our line was 3x minus y equals 9. We found that the x-intercept on this graph is going to be 3, 0. 1, 2, 3, 0 right there. And we found the y-intercept of this graph is going to be 0, negative 9, which is down here. 3, 4, 5, 6, 7, 8, 9. And we know that since our equation is the equation of a line, it's actually in standard form here, all we have to do to find the graph of the line is connect our dots. So something like that. That gives us the graph of 3x minus y equals 9 just by finding the x and y intercept. This is a pretty simple process. To find the x-intercept, you always substitute in y equals 0 and solve for x. And to find the y-intercept, you always substitute in x equals 0 and solve for y. It's a pretty simple process, so I'm going to leave it at that, and we're going to move on and talk about horizontal and vertical lines. Sometimes we'll have an equation of a line that looks a little bit different. Let's take the equation y equals 3, for example. Now what we did in the previous video is we chose a bunch of x values. We said 0, 1, 2, 3 for example. And we plugged those x values into the equation to figure out what our y value is going to be. Now in this equation that we're given there is no x, so we have nothing to actually plug into this equation. No matter what x we choose, y is always going to be 3. Now if we plot those points, 0, 3, 1, 3, 2, 3, and 3, 3, we get 0, 3, 1, 3, 2, 3, and 3, 3. You can see what we're going to get is actually a horizontal line. And the horizontal line is going to go right through the y value, y equals 3. If, on the other hand, we had an equation that looked like, say, x equals -2, we could notice that no matter what y value we have on our graph, our x value is always going to be -2. So our x value, no matter what y value we choose, say 0, 1, and 2 or something like that, our x value is always going to be -2. And if we plot those points on a graph, -2, 0, -2, 1, -2, 2, -2, 2, we'll see what we're going to get is actually a vertical line. And our vertical line is going to look something like that. So here's the rule. Whenever you have an equation, y equals some number, it's always the equation of a horizontal line. Whenever you have an equation, x equals some number, it's always the equation of a vertical line. This video is pretty short. Let's get you your quiz. The video quiz is find the x and y intercepts of 2x minus 3y equals 8. Also, separately, graph the equation y equals -4. All right, good luck. I'll see you in class.